is to understand it. You really don't feel comfortable with it for a while. But this is X-Ways. Now, X-Ways Forensics is a tool that you actually use as a hex editor. It started out as a hex editor, but it can parse operating systems and file systems and things like this. And you can take things apart. And it has some very helpful information for crawling back through an operating system that most hex editors do not have. And so one of the big benefits here is I'm in a folder. I'm on a hard drive. I'm on my local C drive on that laptop. And I'm in the partition. I opened up the partition, my C partition. And now I'm in the Documents and Settings folder in my desktop. And this is a file. Now I left this one up here actually as a benefit so that you can see, all this time we've been talking about JPEGs and we go search for a JPEG, what there is FFD8. Every time we've been saying I'll search for a header, FFD8. That's what this is. And so this is the beginning, and at the footer, all the way at the bottom, there'll be an FFD9. So it'll finish with that. All that happens is a tool carves from here to here. All it does is cut and paste. It's actually cut and paste. It's copy here to the end, paste it out to a file. That's what it does. So, and you can do this all day long, over and over and over again, from a file, inside a file, outside of a file, from a drive, from anything. Okay? So now this file by itself is just raw data. This is just raw data. There is nothing that tells me. Now, aside from this, the fact that the camera, they added a component called XF. So basically, XF information is extended file information. So that's basically what we're looking at is file information. Because it could not store it at the time in the file system, which exFAT can do. It can't store it in the file system in a camera. So they made it so it stored it in the picture. So this is not the actual content of the picture. This is a header. Then they stored some XF information about the camera, the date and the time and the other stuff. And then the real picture actually starts down here somewhere below it. Everybody understand? So in the file system, there's a date and time. Those are modified, accessed, created, and there's also a file name. A file name, there's no file name in here. There's no such thing in the raw data as a file name. The file name is a component of the file system. Right? It's just raw data from end to end. If I destroy the file system, all I have is raw data. And then I have to make up names. And I have to make up what this content is. So this picture is called test1 JPEG. This is outside of that. So now I want to see where this is in the file system. And this is one of the unique things about X-Ways is I can click on it and I can say, go to the record that explains what this is from the file system. Okay? That's one of the nice things that it can do. Other tools can't. Or not forensics tools. So I can go here and I can say my position, my mouse is moving. My position is the file record. Now remember, we've been talking about, I showed this earlier, like how does an MFT entry know where the content is? The $MFT contains thousands of these file records. So you have file records. They begin in the beginning of the raw space as file, and then they contain all the pointers to your data. And those make up components of the MFT entries. Understand? So I'm going to go to that record. Now, I am not in test 1. I am not in test 1. Test 1, that raw data you saw earlier, was all the raw data down in the disk. I am in the file record. This is the description of the data of where it was. Is everybody clear? This is the collection of MFT entries. This is my catalog. If I copy to my $MFT, it will give me, like an Excel spreadsheet, of a whole big list of all my files. So, in the file record, it is 2 sectors big. It is 2 512-byte sectors. If the file was smaller than the file record, it will store the file in the file record. Okay? So if it's very small, like here's a link file. See that WinHex link file? That's small. That is probably resident. So for instance, if I click on that, then content would be there. See, there's actually content in there. Does that make sense? Stored in there with the file record, and they actually belong together, or they would normally if it was small enough. But back to this. JPEG, I'm going to the position of the record. So this is now the record. And X-Waves color codes things so we can figure stuff out quicker and things that are broken up together. Then normally a viewer like this would not show you this type of content. It would just give you just raw hex, and you wouldn't have all these pretty stuff. So in this record, I'm trying to show you how scan disk and check disk work. So this file record is 2 sectors big. So in the middle of the sector, in the middle of this record, there will be a breakpoint every 512 bytes. So at 512 bytes, see this? See that dotted line? That line is the break between sectors. So if I had a file record and it was like the beginning of a file record, right here it would say file. Because it has to be at the 512 byte boundary. This is a sector. It doesn't just appear in the middle. Every sector is broken up and the content is specific to that sector. So every box you open has to have one thing in it. Okay? Makes sense? Now, this whole thing, even the empty space below. So here's one record, file, and then you'll see the rest of it to that. Then there's a second record. So it's 2 sectors big. And then there's another one. Everybody understand? Now, this is all that extra space. So you could have like a long file name. You can have other attributes and things that are stuck in there. Now, this one doesn't happen to have a long file name. This one's a very short file name. And so, test.1.jpg, blah, blah, blah. So it says here. But if it was test Superman loves Lana Lane, blah, blah, it'd be all the way down here. They keep on going into the second sector. Understand? Now, at the break of the sectors. Now, I want you to think about this. You're 1984, 1985. And you're like, hey, look, hard drives don't keep track of bad sectors and stuff like that. How are we going to know if stuff is written correctly? Like the guy opens a file, he edits it, he makes a change to a file, now it updates a record. How are we going to know that it updated a record correctly and the system didn't crash, lose power, power supplies didn't exist, transactions weren't easy to back out? You know, SQL, people know SQL Server does things like this, right? That's the big thing about SQL Server. Is you have a database, transactions happen, it follows the transaction. If something happens and the server crashes, it backs out the transaction when the database comes back up. It knows it's incomplete, right? People have heard this, right? That's the whole point of the transaction-based file systems and operating systems, things like that, is to back those things out if something bad happens. But you're in 1984, before this stuff even exists. This isn't like a normal thing unless you're a Unix guy and it already existed and they could have just used that. But it didn't. Right? So, you are thinking, how do I make sure this stuff is there? So here's what they did. It still exists today. This is still the way it works. Your file record. Inside here, there's a bunch of attributes. And these attributes all have different things. And it's not file 0, by the way. Depending on which operating system, this is a delimiter, and it starts right here where the 0 is. This is now attributes that point to stuff. Sizes and big clusters and dates and times and all this other stuff. I'm not going to go through all that right now. But if it was formatted on Windows 2000, it would be asterisk. It won't be a 0. It would be an asterisk. Because that's what the delimiter was when it was Windows 2000. And so those are pointers to content. Now, in here, there is something. It's called a sequence number. The sequence number says, every time that I use this MFT record, I add 1 or subtract 1. So if I delete something and change something, I subtract 1. If I add something or make a change to it, I add 1. And it's a sequence number, and it adds to it, okay? The sequence number is these 2 bytes. Right here. OD and that. And they're not the same. Like, it'll add, and so when I make a change, it'll be a different number. So another file records are going to be completely different. If I go down here to a different file record, then you'll see right here, they'll actually have a sequence number, and it'll be different. That sequence number is... half a second here. I can't see this on the screen. 03. So the sequence number is right there. It's 03 for this one. Okay? So that's what this one is. And then there's content following this. This is called an array. This is a storage container. When you write a file, it goes and makes the changes. And it updates all the dates and times. And at the very end, the last thing it does is it goes to the bottom of the first 512 bytes. And it updates a counter there. So where 03 is here, it goes down to the bottom of that 512 bytes. How come I can't see that? See this right here? 03. Now for forensics people, there's like slack space and stuff like that in here, because the file name doesn't overwrite the old stuff, so the old stuff that's in here could be slack space. Slack space is the remainder of stuff that's not overwritten by the previous stuff. So when you fill a container, you don't completely fill the container, what's left is slack space. So the data might only be this and ends right here. But before this file was written here, there was another file here, and all this stuff existed. This is slack space. This is junk, is trash now. It doesn't actually exist in this file. So we can find stuff out about stuff even in file names, about stuff that was previously there. And this is actually text. So this was a small file. It was a small file that existed inside the record. And we have content that is there. Does everybody understand? Okay? So physically inside the record there is other content. Now, in here, where's the dash? There it is. Okay. See this? 03. That 03 matches in this record 03 right here. See that? So it writes content, makes a change, the sequence number got updated somewhere along the way. At the very end, says I'm done with this transaction. Let's take this information from the transaction sequence number that has been updated, and we will replace this with the last 512 bytes right here at that boundary of the 512 bytes, right before we change to the next 512 bytes. Understand? Now, there was content there. There is content that should be there. I mean, look how Java. What would be the next letter?
T.
T, right? But it's not there, right? So that should be report, and it's not there. Well, that is stored in array. So whatever bytes were there get moved. So they take the 2 bytes that are there and they copy them. So they took those 2 bytes and they put them in the array and they moved them. And then they wrote the 2 characters that were the sequence bytes there. So scan disk and check disk, what they do is they run through every record. They have 3 phases, and one of the phases is, did the transaction complete because it crashed? So since the dirty bit flag was set in the volume name, I knew I crashed. I'm going to kick off scan disk. When scan disk starts to run, it looks at the file records, goes to the delimiter, and it says, does 03, this byte, match the bottom of that? If the answer is yes, move on. If the answer is no, delete it. When it deletes it, it considers it a bad record. Have you ever seen BAAD? It replaces the file record when that happens. When that happens, it will no longer be called file. It will replace these with BAAD. And it's only called that because it needed 4 spaces for it to equal file, because it would have been BAD, but they for some reason decided BAAD. So it's bad. Okay? All right? So this is what ScanDisk and CheckDisk use to tell whether or not a file transaction has completed or not. So it's kind of really a cheap way to, I mean, it's very simple, but it's very cheap kind of thing. There's not a lot of transactions that go on there. So let's say, for instance, we opened up our hex editor, we changed one of the 03s. If we update the file, it will update without us knowing anything about it. It'll just update those and it'll match again. If I change one of the 03s and I pull the plug and it crashes and it restarts, it'll eat the file when it starts again. And it will not leave a record behind here at all that the file existed. The file will become unallocated. Everybody with me? This is what ScanDisk and CheckDisk do. There's no recovery process here. It just says, oh, transaction didn't complete. Gone. Out of here, dude. So
There is a /R now, doesn't it? Isn't there some kind of an attempt now to fix
If it,
deep attempt, but you know.
yeah, I mean, it's very rudimentary and not very successful, and there is a way for it to try to go through a repair process, but in the process of doing this, it will still kick out and throw away transactions. It believes this is an incomplete transaction. It doesn't believe that there's something wrong. It just believes that there's an incomplete transaction, that during the process of writing, that the system died. So therefore, don't keep the update, go back to the old file. If it deletes this record, then the old file never gets removed. So therefore, there is no other record because it would have died before it finished that record. Do you guys understand what I mean? So that's the transaction process. Now, skip ahead to Windows 7. Windows 7 has a whole new process called the SelfHealing Thread. When you touch it, it checks it all the time. ScanDisk is running in memory all the time. When you do this, if you edit the file, it will remove it from the folder right away. It'll disappear right away. So if you wrote a virus that said change the last 512 bytes of every 512 byte record, your files would disappear. It will eat them. I can do it live. The only problem is I only have one Windows 7 machine, and it's not hooked up to the projector. But all I have to do is go into there, find a file record, change 03, refresh. That's it. The file will disappear from the directory. It's gone. So it does a self-healing thread, Windows 7 and Windows 8. Most people do not know this exists and do not even understand what it means. There was a lot of talk about how Windows would repair itself. It does it on the fly now. It does not depend on ScanDisk or CheckDisk to reboot and run. It'll just delete it right now. Cool? I think it's neat. It's really awesome. I'm going to do a speech on it one day because it's really awesome to see this happen and actually get deleted.
Why do we still have CheckDisk in Windows 7 then?
You can still run for other phases, and there's more stuff that it can do, but it checks this record to see if the transaction was complete all the time. If you want to write the coolest virus ever made, just go into a Perl script and just make it every 512 byte record, just change the number, and as the files start deleting, eventually your system's not going to run. But there is some, and this is weird, there is some protection for Windows-based files that are necessary for the system to boot. So for instance, you can't kill it or it won't remove like the bootable EXEs or the bootable DLLs that are necessary. When you change the number, it won't remove them. But it removes files, other files, anything else that's running, program files and things like that. Those can all be deleted or it will see these transactions. It just has some sort of a protection for Windows-based system files that are there. But this is part of those checks that it does too to see, you know, are you running the original version or there's other stuff. And there's other code that's actually in there, but there is doing a physical check against the drive to see whether or not this record. But this should also explain a little bit better how the file system works, because this one file, this one thing that says file, describes completely the location and the content of the file that's associated with this name. It is the only place it exists, but that's it. And this, I only need one record to survive to find this file. These 2 bytes are all that need to, these 2 sectors are all that needs to survive for me to find everything about this file. Understand? So that's kind of cool from a recovery standpoint, which is not true in Windows or, I mean, in Mac OS or in, because once this record is destroyed or the chain is destroyed, it's very difficult to recover from it. But see all this blank space right here? See this OD? So even though there was nothing else written here and there hasn't been any other file, you'll still see the sequence number, and the sequence number is still updated up here. So right under there, OD, and there's just nothing else. These are just blank because there was nothing to copy. So it's 0. And that's how that one came from the JPEG. But play with the self-healing thing. It's really awesome. Deletes. Okay? All right, so back to these records in NTFS. In NTFS, when we are dealing with the records and they mount, I plug this into Windows. Now this is a story that happens all the time. Guy calls Geek Squad, says I want to upgrade my computer, I want to do something. The Geek Squad guy comes in. He takes the owner of the, the CEO of the computer out of the CEO's computer, the hard drive out of the CEO's computer, and plugs it into an external device. Plugs it into Windows, and then starts copying all stuff. I see people do this all the time, right? They do this, just to describe it. They do this. They take somebody else's hard drive, they go into the C drive, they do this. Right click, copy. And then they paste this over into their other drive, right? That's how they copied a drive. You've seen this happen, right? All right, then they reformat the drive, reinstall the operating system. They put all his tools back on there, his stuff back on there. And then the CEO comes in, he sits down and he goes, I'm missing some stuff. And the Geek Squad guy goes, well, what you missing? And then the story is always, oh, my email, my PSD file, my desktop, all the content, all the stuff I had, right? So at this point in time, what has happened? Why did he miss it?
Because he didn't point everything back to its original location.
Nope.
It wasn't in a native environment. He put it
Oh,
over in his,
right.
and so he couldn't see anything.
That's correct. It's not in a native environment, so he could not see everything. And then he didn't point back to the right folder or file or whatever, right? So physically what happens is, if you're looking at the content itself and you're looking at the way that this works, so here is a hard drive I got from a client. And so it says it's C, because that's the label, but it's really my F drive, right? And so in that, there is Documents and Settings folder, and there's a dude named Snow Cowboy. And Snow Cowboy is real. His real name is Snow Cowboy. So he turns on, protect my files, right? That little question when you create a user and it says, would you like your files to be protected, sir? Yes, okay, click. You know, which is also the same command does. Would you like to join a domain? Yes. It's the same thing, basically, right? So the only difference is what it combines for RID and SID to join the domain blah. All right, so Snow Cowboy. You click on Snow Cowboy, and you click on this folder explicitly, and it will give you, abort, you cannot get in there. This is completely a permissions problem, right? But now I did Control A, and I highlighted everything, and then I copied it. So if I did that here, like I did on that drive, and I copied it, what will happen when I get to Snow Cowboy?
Nothing will copy over because you don't have rights to it.
Right, nothing will copy over anything. What warning will it give you?
None.
None, not a single thing. For some reason, you don't have rights, so therefore you should not even know. So we don't even bother to tell you. So you are Bob, and Sue has files, and you should not know what files Sue has, because if I even told you the file name, that would be bad, because they're Sue's files. It might say something like, me and my husband on a trip on vacation, blah. Like, they don't want you to know, right? So it's just going to do nothing and skip it. What about the other folder? What about the recycle bin? What's going to happen?
Nothing. Access denied.
It's not completely nothing, almost. What does get copied?
The SID, the other SIDs that are,
Yes.
authorized are not protected.
Right. You'll get the SID number, like you'll get your own SID number, and you'll get the content from yours, and then the other folders that are the SID numbers for the other trash cans that don't belong to you, and there'll be blank in there. There won't be anything. Right? You just get the folder, and that's it. There won't be anything. It'll be done. Right? See people seen these? You know this when you're copying stuff over? So this is bad news, which this whole problem, because here's the other thing, and some people might not realize this, because you're going to get 0 bytes if you look at that file, right? It's not 0 bytes. It's not 0, right? So I want to point this out. This is another thing that just happens to happen with the system that until today you didn't realize. People do this all the time. How much data is on this drive? What's wrong with that?
It doesn't count.
Doesn't count any of those, right? Those are all going to be 0. It's not going to be the right size. So when the Geek Squad guy got done, it actually said, I did 32 gigs, and this did 32 gigs. So yeah, I have 32 gigs. I did it. It's awesome. Okay? This takes a long time too, right? This is counting the files individually. It's going through the records, going back to the MFT, looking at them, coming back, looking at the files, adding them up, moving on and on and on, right? But watch this. Why is that so quick? But the other actually had to sit there and count.
Using not the MFT.
Not the MFT. What tells you allocated and unallocated? What?
Is it
Allocated and unallocated.
The cluster bitmap.
That's correct. It's the bitmap. This is the bitmap, and it will tell you in actuality what is allocated and unallocated. So if you wanted to know the difference between this, you would look at the actual drive and what its sizes are, and not the content of the drive. The content of the drive has to crawl through, and not only is it not, because it's not just touching the MFT entries, it's going and pulling that and it's crawling through it, but it's doing it specific, comparing it to the SID numbers to see what you have protected. So those two things are not necessarily going to help you with your answer. Whereas this right now, if I was the Geek Squad guy and it said 32 gigs, and then I go and look at this, I know immediately there is a lot of junk on this drive that is not mine. And this is how pirates do it too. Like, you see people break into your system. They go into your trash can. They make something with a character you can't see. So basically you can physically make a directory that has a character that's untypable. And then in that directory, they put an FTP server, and they start sending files back and forth. And they'll have, you know, all the French movies and whatever they'll be sharing with their friends over FTP. And you never know it's there, but your drive is full. Why is your drive full? Then you could see that it is full, and slow, and slow. And your internet service provider is going, hey you, pirate, what's up? So anyway, so the whole point is that you can do this and make these in other folders that aren't viewable, and by doing Control A and highlighting the stuff, you're not going to see it. But this will tell you right away when my drive is full or not, because it will be allocated, and the MFT entries will track it. And data recovery software can see it, even in those other folders, right? So if I did this, I could just bypass this problem altogether. All I have to do is do something like this. So this is our studios. I look at the C drive. There are two ways to open this. I can basically go through a scan process. What does scan do? It'll look at every single sector, every location. It'll carve from a table. It'll look at headers, but it will also look at MFT entries. So it combines MFT entries and scans and all these other stuff. But this one is just the MFT. This opens just $MFT. So when you actually look at this, it completely ignores all the other tables that are unnecessary. I mean, it may pull volume, but other than that, it didn't even pull volume. And so other than that, it just pulls your MFT entries. This did not touch data. This touched $MFT. I can click on this and I can see what files are in there. This is from $MFT. That's why it's lickety split, as opposed to I went to a directory in Windows and it had to parse it and go through the whole process. It's not skipping around on the drive or anything. This is $MFT. Happy? Good? This is awesome. That means I did not touch the rest of this drive. I only touched this. Then when I go to actually extract it, it's going to then look at the content, go collect the clusters, and go expand it or do something with it. So I can physically get rid of this content. There's another tool that it is called Disk Explorer for NTFS. We're going to talk about this one in a few minutes. But I can sit here, I can go in through my drive, I can go look at a root directory. This is now all my entries. I can go find a specific entry and export it based upon its clusters and its location without thrashing all over the drive. No security, no problems. Make sense?
Now, once it's on the other drive, if you try to access it, it'll have the same security?
So, in this tool, it would strip it out. In this tool, if I did that, so these are some of the attributes you can keep and you can strip out. Like for instance, it's a hidden system file. You can strip some of this out. And then the other one is on this side where, and there has been an update, and I'm not running the update. There's another one, but this one, see here it says recover security. So you can recover your security settings and all the stuff that was associated with that for your MFT entries. We would not normally want that. But I would also change so that hidden attributes and stuff, because otherwise, if you don't change the hidden attributes and remove them, and I normally do not, because I normally would not overwrite files either. I would tell it to rename them, because when you're recovering temp files, sometimes you'll have two temp files. One of them will be the trash and the other one will be the right one. And so like if you've got a damaged drive and something happened, the original file might be damaged, but your temp file that's left over from a previous word occurrence or something might actually be the right one. Okay? I'm going to explain something with that shortly. Everybody okay? So that was kind of the whole point, is that you could just bypass all of this. And I swear, you know, ATM for hard drives and for equipment made a drive called an Opel Drive, where you can use some configuration tools to set up sectors that are only available to a certain user, so that the sectors are not available to somebody else. So basically you have to have multiple setups, and then the MFT will be set up differently from each drive, but that's not a lot different than swapping out the drive either. So cool? Yes? No? Okay, good. Okay, so now here's the other thing. This is also another misunderstood thing all the time. People have heard about the MFT entries themselves. They get pre-allocated at the beginning of formatting your drive and setting them up. XP and earlier reserve 12.5% by default. You can play with that number. I don't know a single person who ever has. 12.5% of your drive is allocated for your MFT immediately upon format. Vista, Windows 7, and Windows 8 all made changes, and they're all different. Okay? They all allocate different amounts. Windows 7 fundamentally sets up 200 megs, and then it can grow or shrink or expand. And then Windows 8 made a change to the size of the MFT Buffer Zones or something. So they're like 256K instead of, standard 4K or 8K records or whatever they were. So they've made modifications. You'll have to do some work with them to figure out what those are. But here's the thing, 12.5% of your drive is reserved right away. So you have a 1 terabyte, you're going to lose 125 gigs of your drive to the MFT zone, right? Now it doesn't keep it. As you don't use it and your drive gets full, you'll have smaller number of records than you have space. It will decrement the size of the MFT zone automatically on its own as you need it for space. So it will reduce its own size on demand. Does that make sense? Everybody good? So most people don't realize it does that, and that it's not permanently reserved. It's only reserved until it needs it and then starts to remove it. Now in solid state drives that would be bad, right? In solid state drives you'd be reserving space and it'd be swapping that space around. So Windows 7 and Windows 8 changed it because of solid state drives. So that's why they're reducing the size and reducing the amount of space that they previously reserved and how big those blocks are. So Windows 7 and Windows 8 changed this on purpose. Okay, we talked about file sizes, scan disks, blah, blah, blah. We talked about this, formatting NTFS. Here's the thing with NTFS. When you format NTFS from one system to another, somebody did some research and figured out how many files you would lose if you just reformatted it and reinstalled the operating system and did not install other stuff. If you took NT, or if you took Windows XP, let's start with Windows XP. If I took Windows XP and I reformatted it with another Windows XP machine / whatever, and I did not do anything except reinstall, it would only overwrite something like 35 files. 35 existing files would get lost, but they're mostly system files. They're not user data. So your user data is still completely recoverable because the records are still in the MFT reserve zone. Understand that that's all that slack space I showed earlier? Those will still exist. They just don't exist to the current MFT. They only exist to the other one. So if I clicked on open the MFT entries, it would only find the current ones, not the old ones. I'd have to scan for them, like we talked about before when you reformat. If you reformat the drive with Vista or Windows 7, it overwrites 230 files. So you roughly lose 230 files. Again, mostly system files, not user data. And then when you go to Windows 8, I think it was 240 files. So there was a smaller number of some of the stuff that got overwritten. Again, system files. So completely recoverable in most cases. Once you start writing data, you start having situations where certain files aren't recoverable anymore because you overwrote a certain amount of the space. So at least from that standpoint, the tables are still there. It's still recoverable. It's not like it is in FAT where it gets overwritten and it's unusable. Windows Vista and Windows 7 and Windows 8, you know how you did a quick format? Well, in XP, quick format, all it did was slap down some new tables. Long format did a check disk basically across the entire disk, and it would only check to see if any of the blocks were bad. It didn't do anything to them. So if you had data that was there, it would not change them. It just checked them. In Vista and Windows 7 and Windows 8, it erases external media. It will make it 0. Long formats make it 0. Not quick format, long format. So if you have a user who plugs in an external drive, had a bunch of folders on files on it, the default is to do a long format. If it does a long format, it will erase the entire disk. It is unrecoverable. Anything anybody didn't know? Did you guys already know that?
What? I don't understand. Wait. If I have if I'm formatting the external disk, or if I'm formatting.
When you format a local disk, if it was the boot disk and you reinstalled the operating system, it would know that the operating system was already on it. It would make the Windows folder windows.old, and then it would reinstall the operating system on it. It does not erase the whole thing or format the whole thing. On an external hard drive, when you format it and you leave it as long format, it will wipe the disk. Vista, Windows 7, and Windows 8 will wipe it.
On an external drive?
Yes.
Not the main?
The main drive, unless you were physically, like you took it out, put it in another machine, and you formatted it, it will not do it on its own when you are reinstalling an operating system. So when you reinstall it and you tell it to go ahead and install the operating system, it won't reformat it. It'll make Windows to Windows.old, then it'll make a new Windows folder, and then it will reinstall on top of itself, and you'll just overwrite files, but it will not erase it and make it 0. This is actually what an external drive looks like when Windows Vista 7 and 8 erase an external media with long format.
This is not recoverable from
This is 0.
the, what is it, the 5280 or whatever?
Right. Well, I don't know that was the plan to make it 5220. So it's the standard for standardization for DoD format. I don't know that it was meant to do that for that particular reason. I think Microsoft has taken a stronger stance about security. So really what happened is, over years, people have beat Microsoft. I don't know if you've noticed, but like over the last couple of years, Microsoft's had a really good stance on security. People believe in them somewhat, which used to be, why doesn't Microsoft take a stand? And people would beat them up about it. And now it's the other way around. Now it's, why doesn't Mac take a stand? Why doesn't Apple take a stand against security problems? And so Microsoft took a real active role and hired a lot of top guys to come and work for them and do stuff. And I know quite a few of them that have physically done a lot of work to make the operating system much more secure. So things like roaming memory, like it makes memory move around so you can't find segments so that you can break into it. Things like that. Changing the rings where stuff is. So some of the stuff they've done for drivers has been to move security into certain rings so that you don't have access to it from the file system. Huh? Yeah, it has to be signed. There's a signed issue. Then there's the protection modes for executables. There's a whole ton of stuff so that memory can't be overrun. There's sandboxing. They've added a whole lot of stuff to make it really secure and very stable. And so I think that was their stand, was old data, when we reformat a hard drive, if they leave it as a long format, shouldn't we just erase it? And that's what they do. They are the first operating system I know that takes a permanent stand against erasing data. Macs, on the other hand, have a script that runs daily, weekly, monthly. And under certain circumstances, during their cleanup routine, they will erase free space. So it is part of Mac's routine during certain cycles to erase free space after defragmenting. So you will also see the Y with the umlauts over it. That's the Mac's cleanup process during looking at this other content, and it will erase content. And so it makes it much harder to find older deleted data. But it is mostly contiguous. Most of the data will be contiguous. So, everybody okay? Did I answer your question? So just know, 0 is 0. Now, if you took a hard drive, somebody gave you an external and they said, I formatted this on Windows and now it's gone, you at least know enough at this point that you might be able to get a hex editor. There are free ones. Hex Edit, as an example, is one of them. You just go download it. Open it in the drive. And if you see that, it's over.
$800,
right.
It's over.
But, well, the $800 isn't going to get it back. It's not coming back. My point is that what happens most of the time is, what if I gave you a drive and you plugged it in and it was working and Windows mounted it and I said, find my deleted files, what are you going to do first? Probably scan it, right? You're going to open some program and scan it. Do you know in half a second you can tell if this whole thing is blank? Just open it up in a hex editor and take a look at it. And hex editors, for the most part, are free. A lot of them are free. Or you can use FTK Imager, which is free, and you can just scroll through the drive. So this is a big problem with RAID arrays. Somebody gives you a RAID array that they tampered with. Every IT guy tampers with the RAID array when it dies. Like, I got to get my boss's stuff back before I get fired. And the problem is, what drive will you find data on?
All
Usually when I get a RAID array in, the only one that has data is the broken one he couldn't access.
right.
The rest of them got reset back up. as a new RAID array because they call Dell or somebody like that and they say, hey, and they'll tell them walk through the RAID array configuration. And they actually reset them back up. And then it scrubs the drives and resets them back. So the only time I find data is on the broken one that they couldn't access. The rest of them will be blank. They'll be completely scrubbed and blank. And so that's the biggest problem we have with RAID arrays is the guy set it back up and did something again. So in 5 seconds, I check RAID arrays. Like if this drive is working and I plug it into the DeepSpar, it works fine. I'm scrolling through it to look and see if I have any data. So, all right, anyway. Orphan files are files that no longer belong in the same tree. This is where we talked about the documents and settings folders and we would have 2 of them. Like 2 documents and settings folders because the orphan no longer belongs to the same tree. So therefore it doesn't know where its parent is. So therefore you'll see 2 in a folder structure, right? Good, everybody happy? Those are orphan. Sparse files. If you do not mount your file system, you do not get the catalog back, sparse files will not come off of the system correctly. Sparse files you can think of as compression. What it does, removes all the zeros. This is how a recovery can grow in size. So you see this, the actual disk space that was supposed to be consumed is 17 gigs, but it got rid of most of the space that had nothing in it, and this ended up with just 7 gigs of meaningful data. Now it's actually going to extract to 17 gigs. This goes all the way back to Novell. Novell was one of the first ones I know of, well, Unix, but Novell is one of the first ones I know of in PC land that used sparse files. Everything that was stored on Novell servers was sparse. And so it would physically compress the content and then would make sparse files. And you had to, when you copied them off, they would come off. You could store much more data on it than the size that it said because it would get rid of the zeros and do compression basically on the fly. So it's still a problem if you had to do Novell recoveries. Anybody doing Novell? Really? I do. I get them occasionally. The problem with Novell now is that you got to recreate a server to copy the compressed files up to so that you can copy them back off uncompressed. There's no uncompression tool. So you've got to create a server. So I have all the way back to Novell 2. I have Novell 2. I have all of the copies. I also have all the books. I have all the stuff. I also have OS2 Warp server. I have had to do quite a few things along the way here. So fragmented files. Now here's something where maybe I can save you immediately some money. Most of the time, fragmented files are going to be a mess. You really can't save your life from fragmented files, right? If they're fragmented and you can't find the entries for them, they are going to be a mess. Does everybody understand this part? The file is no longer contiguous, and so therefore you've lost the entry that will tell you where your file is, so therefore you carve, and you'll have a JPEG with some junk in it, and then some more JPEG stuff, and it may not even look right. Everybody okay with this? So, once upon a time, there was some professor. And there was a professor who decided that mathematically, there is no reason why we could not recover some of these files. And a JPEG graphics have a dithering algorithm. So there is a mathematical process by which you know what the bit next to it should be, right? In 2003, 2004, they wrote a tool that was a proof of concept tool. And then they released it as a little $20 tool. And so it was physically a tool that you could use that would scan a hard drive, find the JPEG, find where the JPEG did not finish and did not have a FFD9 in a footer, and search for the next bits in the algorithm that would match that. Find the picture and continue on the picture. Do you guys understand what I mean? So they wrote this tool. And there's always some danger I'm going to go to this website and it's not going to be there anymore. Some of you will recognize, let's see if I can find, give me a second, I can't type in that direction. Yes, I am in the hotel. Please connect me to the internet. Please let me in. I am a dude. Your name is. I agree to your terms of service. Okay, now let's see. All right, Some of you may have seen this. You do forensics, and you may have seen this tool before. Anybody ever seen this tool? Yes? No? So what happened is these guys released this tool, and it was basically 20 bucks. And somehow somebody said, look, you know, these data recovery guys are not who this tool should be for. What you really should make this tool for is forensics people. Because you could charge a shitload of money for forensics people. You could make a lot of money off of this, and that's who needs it, not data recovery people. So I guess they decided this was a good way to go. So what they did was, it used to be called photo recovery and adroit photo recovery. Now they changed the word to photo forensics. And this $20 tool, who can guess how much it's going to cost?
$1,200.
$1 million.
$195.
Oh, wow.
But it's got a dongle.
It does. It has a dongle. So here's the thing, though. So it's really, to be honest with you, the interface is so simple. It really is just point at a drive, click the button. They have a training class. I do not know how they have a training class. The police in New York have taken it. A couple other people have taken it. It's a whole day long about how they explain how it works. But it's one button. I'm not kidding. It's one button. Click a button, spits it out. And so it actually looks across it and sees the stuff. Now, the thing is, you'll notice nowhere on here is what used to be the $20 tool. All right.
Can you do the Internet Archive?
Wait.
Way back?
Wait.
Hey, you're spoiling it.
All right. If you know the website, photo-recovery.info, you type this in, you will also notice there is nowhere to buy it. This is some piece they left behind, and they still updated up to a certain point. They had changed the price. It's actually now like 30 bucks or 40 bucks. But here's the thing. Here's how you get it. You download the executable. You run the executable, and sometime in the middle of running this executable, it'll pop up a box and say, please buy me now. You click buy, it'll take you to a $30 page, and you'll pay 30 bucks for it. They'll email you a serial number. It is not bound to the machine. And as best I can tell, and everybody who has ever run it, including the police in New York, as best we can tell, it's the same one as the dongle. We don't see any difference. I cannot tell the difference at all. So there's always a chance it won't work one day when I tell you to do it, but I bought like 3 copies or something at this point and in my tests, it will recover about 30% more files than you will normally see. They have some other big massive claim, and I don't believe it. I see about 30% more files that are deleted that I can recover than I can do with deletion and fragmentation. Does that make sense?
And it only recovers photos or everything else?
It only does photos. It only does pictures. Now somebody did make they did make another version that did do, now I'm on a Mac, it's not going to execute, but they did make some other guy made a version to do a similar thing for MP3s and for movies, which I think is almost ridiculous unless you're making your own MP3s or something like that, because you can go download them or anything. But their proof of concept tool wasn't as good, and I don't know that they're even selling it at this point. But there was some work done for MP3s, because it's the same kind of idea. There's algorithms that go with that.
What state does the drive have to be in for that to run?
Well, you have to already have done your recovery, already made an image, already have your stuff, and then now we're looking in the logical data for something that's corrupt or damaged or something like that.
You're in test disk, and it spit out.
Now, see, test disk doesn't do unallocated space for. Right? So what you need is the whole drive. This crawls through unallocated space. So you make a DD image or an image or a clone or point it at the whole drive. So you can do any of those things and then spit that out. And so it'll look for it. But this, like I'm telling you, it's 20 bucks or whatever. So I just saved you $2,000. That might be worth the class altogether. Right? There's $2,000 right off the bat. So at least from that standpoint, try it, and since the machine is not bound to the serial number, you can move it and install it on another machine. It did not do activation on it previously. Today, I can't tell you exactly what it did, but buy it and see them for 20, 30 bucks. It's not bad. Okay. All right. Offline files. Now this happens, and this does happen from time to time in data recovery. Small office gets broken into. Server gets stolen. CEO's on the road. He used the offline file sync that's built into Windows, and he now has all of the archived of financial files because the CEO, when he travels, wants the spreadsheets that they use on the server. When he comes back to the office, normally it would sync to the server, and it would just update them both. It's built into Windows. I don't know how many of you used it, but system administrators use it. Do you also turn on VSS admin snapshotting? Do you know what I'm talking about?
No.
Okay.
Usually you have to deal with it breaking.
Okay. All right. We'll talk about that again in a second. So, the files that are stored on his laptop, they are bound to the machine by the SID number. So there is a tool that Microsoft came out with. This is where the files will be. In the Windows folder, there will be a folder called CSC. And it will contain files that you need to recoup, basically. You copy them, so you always check to see if there's a CSC folder on your Windows machines. Then you take those out and you copy them to your own machine, and you download this command from Microsoft and run this command with reset SID. So basically this resets the SID numbers to your machine, and it will then allow you to actually open all of the files. So it's a low-hanging fruit, easy to do, one little command. But if you have somebody whose servers got stolen or a tornado came through and threw the server into the lake, you know, those kind of things happen. And the laptop will have that data on it in those folders. Okay? Good? Everybody happy?
Usually it corrupts and fills up the drive, and then suddenly problems happen because the drive's full. And
Right, with the syncing after it's been done and fills up the sink.
It can't sync, and you usually blow it up.
So when it works, the data is there. All right, here's the other thing. Let me tell you, now this is only going to apply to people who have a Windows Server. Windows Server all the way back to Windows Server, I'm pretty sure 2008. Any of these items that are connected to the computer, you can do VSS admin on. No, back to 2003. 2003 server can do this. You know how Windows 7, how their big claim is that they always back up all your files while you're using them? If you opened up PowerPoint and you deleted a file, that it's still on your computer, that it made a little delta and did a little backup of the file, and so it did a snapshot every day, and that it's sitting in this the unallocated space that's in the volume snapshotting. You guys remember this whole thing you used to do with System Restore, where you could go back in time and you could restore your system, but that only did it for drivers? Well, then in Windows Vista and Windows 7, they made it so that you could actually do updates to the files. And so files are now also captured in there too. Forensics guys know this because they use Shadow Explorer. It's called Shadow Copy, and it's physically in there. They replaced System Volume, the System Restore, with Shadow Copy. Has anybody heard about this? Now the thing is, they claim that Shadow Copy does not work in Home and Premium. And that's not true. What? Yeah, it's there. Right. It's there. You just don't have the tool to get to it. Do you understand? You know what I'm talking about?
Yeah.
So in Windows 7 and Vista, you can go right-click on a folder or a file, and you can say, show me previous version. Have you guys seen this? It's really awesome, actually. It's like live backup all the time. Windows XP does not have this feature, right? Windows XP attached to a server 2003 or later, it turns on that feature on shared folders on the server. So you have a secretary in the office and she deletes a file and it's on the share. You can actually recover it. However, as an administrator, you must have previously set it up on the server to do this. It is using the VSS admin command. You take a blank hard drive, you throw it in the computer. You point that file to it using VSS admin, you point to that drive. And you say snapshot 3 times a day, 1 p.m., 5 p.m., whatever. And any of those shares that are on the server connected to Windows XP, you will now see a show previous version. And you can recover files. So this way, if you're on the road, you know, you get that phone call and they go, hey, I deleted a file and I need it back from tape. Well, right-click on your desktop, look at that file, there it is, or whatever. Right-click on your share, and there it is. It only does it, it doesn't do it on a local drive. It only does it on the shares. But you have to turn it on, and the command from a command prompt is VSS admin. Volume Snapshotting Services Administration. Okay? So if you're managing servers, that is important, because you can save all the files. Good? Good. Great. Okay, next. All right, we're going to do something for real. I want to show you how some people teach labs and they just basically say, go look in a book and look at a lab file. I'm just like, well, of course you don't think you're going to get that from me, do you? I'm going to be involved with you in this lab. And I'm going to walk you through how I think, because my process is to try to teach you what I'm looking at when I look at this. Okay? And all the buttons and stuff that I think of. This is not just to show you a particular piece of software. I do not care about the software. I want you to understand what software does. When you're clicking buttons, don't just click buttons. I want you to think about what it's doing, just like you saw me do. Oh, this one looks at the MFT, or this one scans this. So let's look at what... All right. A hard drive comes in. I throw it on the deep spar and I image it. Works fine. It's awesome. I had hardly no bad blocks, but I had a few bad blocks, right? Now, I'm going to take that, plug it into my laptop, and I'm like, whoa, something bad happened. I can't see what I'm expecting. And this happens to forensics people all the time. They'll see stuff. For some reason, it doesn't parse the operating system. They don't know what to do. So they go and carve files or scan for something, or in case, look for lost folders or whatever. So, so here's the story. There is a tool called FTK Imager. How many people have used FTK Imager before? Just you three. So you guys have never seen FTK Imager, right? Now here's the thing. FTK Imager is useful for you regardless of what your profession is, in my opinion. Well, I mean, I don't know if a ditch digger needs it, but we are going to use it, okay? So now here's the thing. Here's a couple of variations of things that happen. Let's say I get a drive from another country. I don't know how many of you get drives. You get drives from other countries? Anybody? No? Yeah, you do. You get a drive from France, as an example, who is, set up in another code page and they're not in English or something, right? So you've got to give files back that your system doesn't support. You could go and install the code pages and figure it out and try to figure out how you're going to support it and maybe make a zip file if you can figure it out or do whatever. It's a lot easier if you're doing a recovery to use a tool that will capture that, including their language, bundle it up, and give them their file back. And then you have to describe to them how to get this file out. Well, FTK Imager is a free tool, and I use that sometimes to do that. Like, I can't copy the files off of a drive that's in French to my local English version drive without doing some extra work to make that happen. Everybody understand what I'm saying? I can use FTK Imager to do this. Like, as an example, I'm going to open FTK Imager and I'm just going to show you something real quick, and then you guys can see what I mean. FTK Imager, for those of you who haven't used it, it's a little bit like X-Ways that I showed earlier, except that it's not an editor. It is only a viewer. You can view content. You can look at content. It parses the main 3 or 4 file systems, and it may even have been updated for exFAT. So at least you'll see ext, Mac HFS, or NTFS and FAT. You'll see those things fine. And you can export data from them. It's a poor man's Mac recovery tool, as a matter of fact. You can take a Mac that's not supported on Windows, plug it into Windows, open it up in FTK, see the files, export them. Good? There are characters that are not supported in Mac, by the way, on a PC. We'll talk about that. So here's your tree. This is what it's going to be here. Then here you're going to see your files. Here is going to be hex. And then here is a calculator, an interpreter of sorts. So everybody open up FTK Imager 3 on your desktop. Okay. We are going to open this hard drive I have imaged. The folder that we are working in, on this, I'm just showing you where it is, on the C drive, there is a folder called Data Recovery Images. We will be working in this folder to look at the image files that I have made. So inside of FTK Imager, I would like you to go File, Add Evidence Item,